Hello guys, Janendra here. This is a small support session related to theory of computer science, and the first question is related to matrix, guys. And sir has told that we are getting the similar type of questions, so I assume that we are also getting the similar type of questions by just changing the numbers values here. As an example, now in the first question, it has asked to find out the inverse of the following matrices, and they are the first part here. You can see this question. It is a 2 by 2 matrix, and this is a 3 by 3 matrix, and there is a specialty. We call this matrix as a diagonal matrix. I assume we are getting the similar type of diagonal matrix, just changing these 3, 5, 7. And also we are getting 2 by 2 matrix like the same way by changing the numbers here. Right. Okay. Now we'll see what is the theory of getting this one. So you can see this is a 2 by 2 matrix, and how do you find the inverse of such matrix? So the theory of getting a matrix of 2 by 2 matrix is the first of all we'll identify what is this one. I assume I label this as a equals this matrix, that means minus 2 minus 2 minus 6 and 7 minus 11. So this is A. So matrix of so inverse of such a matrix is defined as A into A inverse, that is A dot product of A inverse equals to the identity matrix. This is the theory. Okay. So getting the inverse means we are getting this value A minus 1. Okay. So how do we get the inverse? First of all, you want to verify whether the inverse is available or not. How do we verify whether the inverse is available? If an inverse is available in a matrix, the determinant of that matrix should be non-zero. That is the thing. If there is an inverse available, the determinant of that matrix should be non-zero. So first of all, you want to find out the determinant, and you want to show that determinant is non-zero. That means inverse exists. After that you can find the inverse. So how do we find the determinant? Now our first aim is to find the determinant of A. So I will write here dit A. Dit A means the determinant of A. How do you find the determinant? Determinant means just you want to get this diagonal value, left diagonal and right diagonal. Just multiply these diagonals and subtract. So how do you get? The left diagonal is minus 2 into minus 11, and you want to subtract right diagonal is 6 into 7. Okay, is that correct? Yeah, I think it is. No, this is minus 6, right? Uh, this is minus 6. So this is minus 6, I think. This is minus 6, right? Yeah. So minus 6 into 7, right? So here then plus 22 and plus 22 plus, and here 42. So and this is 64. This 64 is non-zero. So we can say A inverse exists. Right? Okay, now we found that inverse is exist. Then we found that inverse exists, that determinant value is 64. Okay, dit A is 64. Determinant of A is 64. After that, how do you find A inverse? A inverse, to find the formula for A inverse is 1 over determinant of A into adjoint A. Adjoint A. What do you mean by this adjoint A? Adjoint A means just the matrix value. You want to interchange the left diagonal, the element of the left diagonal. Now it is minus 2 and minus 11. You want to just interchange. That means minus 11 comes to the place where the minus 2 is available, and minus 2 will come to the place where the minus 11 is available. Okay, that is the way you are interchanging the left diagonal. And the right diagonal, you have to keep the element as it is, but you want to multiply by negative. Okay, so now my target is to get the adjoint A. First I will write the determinant A, 1 over 64, and adjoint A is, how do you write that one? Just keep minus level in the minus 11 in the place of minus 2, and minus 2 is the place of minus 11, and multiply these things by negative. Now minus 6 comes as plus 6, and my plus 7 comes as minus 7. Okay, now you want to multiply this by minus 1 over 64, then you are getting the last answer. So here you can include this 1 over 64 inside of this matrix, so you can put it as minus 11 over 64, and here 6 divided by 64, and you can put minus 7 divided by 64, and here minus 2 divided by 64. So this is the answer. You can, if you want, you can further simplify. Minus 11 divided by 64, you can't change it. Minus 11 divided by 64, that is as it is. But you can divide by 2 here. So 3 by 32, right? 32. And here also you can't divide. Minus 7 divided by 64. And here you can divide by 2. Minus 1 divided by 32. So this is the last answer. And you can check whether your answer is correct. That means if you multiply this a and a minus 1, these two, if you multiply these two, you are getting the identity matrix. You can check it. Minus 2 into this one and minus 7 into this one. Like that way, when you are getting the answer as identity matrix. We are getting that one, so I don't want to prove it. So this is the last answer for the first part of that one. The second part, it is very much easy. We are having uh, diagonal matrix. Okay, diagonal matrix means only the diagonal has some non-zero values, and except the diagonals, all the others are zeros. So that thing we are calling as a diagonal matrix. So what is the theory of uh, getting the inverse of diagonal matrix? It is very simple. Just you want to reciprocate the diagonal values. Okay, that means it is like that. But in the same way, first of all, you want to check whether the inverse is existing. How do you find out that one? The determinant. We'll take this one as B. The determinant of B. Determinant of B, determinant of B. Now here it is easy to get the determinant of B. What do you want to do? If it is a diagonal matrix, you want to just multiply these diagonal elements. Now there are 3 elements. You want to just multiply 3 by 5 by 7. 3 by 5 by 7, that is 105, and it is non-zero. That means inverse exists. That means B inverse exists. B inverse exists. Okay, then how do you find out the inverse? Inverse, we are getting B inverse is just reciprocating the diagonal value. Just reciprocating the diagonal value. That means you can get it like this way: 1 over 3, and this is 1 over 5, and this is 1 over 7. All the others are 0, 0, 0, 0, and here also 0. 357. So B inverse equals 103, and here 0, 0, here 0, this is 105, 0, 0, 0, this is 107. This is the last answer. Okay, I think you understood that one. So if we get the diagonal values, like see something like this way, 500 090 and 0011. If something, we can easily get the B inverse, like 105 00 01090 001011. Okay. But before that, you want to verify whether the inverse is existing. How do you check that one? You want to multiply this diagonal and it should not equal to 0. Okay.